Alright, this is GL Chapter 3.3, Proving Lines Parallel. In the last section, we talked about given the fact that they're parallel, uh, these 8 angles are either true, congruent, either congruent or supplementary. So, same side or consecutive angles, they're supplementary, alternate interior, alternate exterior, and corresponding, they're all congruent. This section is going to deal with the converse of those. And if you remember from chapter 2, a conditional was in the form of if P then Q, where P was your hypothesis and Q was your conclusion. And the converse is the opposite of that. If Q then P, where your conclusion is first and your hypothesis is last. So we're dealing with the converse of parallel line theorems that we came up with in the last section. So we're now proving these lines parallel as opposed to proving these angles congruent or supplementary. So we're switching the hypothesis and conclusion. So if you look at the first theorem that they give us, this is the converse of corresponding angles. So I write this as corresponding angles converse. So now we're proving the lines parallel. So the theorem says if two lines and a transversal form a corresponding angles and they're congruent, then the lines are parallel. If two lines and a transformal form corresponding angles that are congruent, then the lines are parallel. Here's what this means. If I have two lines and they're cut by a transversal, again, I don't know if they're parallel yet. If I have two lines and they're cut by a transversal, what this theorem says is that if the corresponding angles, this guy's in the top right, this guy's in the top right, if the corresponding angles are the same, then these two lines must be parallel. If the corresponding angles are the same, then the two lines must be parallel. That is the converse of corresponding angles theorem. So here we have this group of lines intersecting each other, and they say which lines is parallel if 6 is congruent to 7. So here's 6 and here's 7. They are corresponding angles if B is your transversal. Since B is my transversal, that means that it's crossing line L and line M. Line L and line M. So in order for 7 and 6 to be corresponding and equal, the transversal has to be B, which means that the lines that are parallel is L and M. Line L is parallel to line M. That was Schottky number 1. And now they're giving us the rest of the theorems and postulates. This one is the converse of alternating interior angles. So I write it like this: alternating interior angles converse, or con. And it says if I have two lines and a transversal, if two lines in a transversal form alternating interior angles that are congruent, then the two lines are parallel. So if I have a transversal cutting across two lines and alternating interior angles are congruent, and I know they're congruent because the markings here tell me so, then these two lines must be parallel. That is the converse of alternating interior angles. Then we have the converse of same side interior or consecutive interior. If two lines in a transformal form same side interior angles that are supplementary, then the two lines are parallel. Meaning, if I have two lines cut by a transversal such that the same side interior angles are consecutive interior angles, the two angles inside here that share the same side of the transversal, they add up to 180 degrees. If that is the case, then the lines are parallel. And this one is the same side interior angles converse. That's how I write them down. And then lastly, we have alternating exterior angles, converse. And that says, if two lines in a transversal form alternating exterior angles such that they are congruent, then the two lines are parallel. Okay, we have 1 and 7, they're congruent, they're alternating interior angles. I have a transversal cutting across these two lines. So, and I know that 1 and 7 are congruent. If that's the case, then the two lines must be parallel. Okay? Every single one of the converses, theorems, and postulates ends with the two lines have to be parallel because they are the opposite. Okay, or the converse of the conditional. Flow proof. A flow proof is sort of like a it uses sort of like arrows to sort of put it in the same direction of a proof. It's like a flow chart, but it's a flow proof. I'm really not a big fan of flow proofs. So what I do, I am way less of a fan of flow proof than I am paragraph proofs. Paragraph proofs at least make sense. Flow proofs can get really, really, really messy. And it's really, I think it's way more trouble than it's worth. It is just gross and nasty and disgusting, but okay. Here we have the proof of the converse of alternate interior angles. So we're going to prove alternating interior angles, converse. I'm going to start it as a two-step proof first. They already show you the flow proof, but I'm going to do it as a two-step proof. It's a four-stepper. And it's always good to do the two-step because it sort of sets you up for either a paragraph or a flow. It kind of writes itself. Start with our given. Angle 4 is congruent to angle 6. In order to prove the alternate interior angle converse, we can't use alternate interior angles converse. That would be cheating. Alright, so I have 4 and 6 that are congruent. I see that 4 and 2 are vertical angles, so I can say that angle 4 is congruent to angle 2 because they're vertical angles. Now look what I have. I have 6 is congruent to 4. I have 2 is congruent to 4, so I can say that angle 2 is congruent to angle 6 because of the transitive property of congruency, which says that if A is equal to B and B is equal to C, then A is equal to C. And 2 and 6 are corresponding angles, so then I can say that line L is parallel to line M because of the corresponding angles postulate. No, corresponding angles theorem. In this class, it's theorem. Okay. Here they have the flow. They have, the same thing. 4 is congruent to da 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 because it's given. And then their vertical angles. 4 is 2, and then they put the arrows together like so. I'm not going to draw it. They put the arrows together like so to say that since this is given, and since this is vertical angles, then I can use transitive property. And since this is equal to each other, then I'm going to draw an arrow and say that they're parallel because of corresponding. They also have, like, a flowchart works really well if it's like 5-6 steps, but once they you have like 10, 12 13, 14, 15 steps proofs, it can get a little cumbersome, which is why I'm not a big fan. Alternate exterior angle theorem. If you have a long, like, 2-column proofs are really good for proofs that are probably, I would say, up to like maybe 10 to 12 steps. Then anything after that, paragraph proofs tend to be better. Flow proofs tend to be good when, you know, 5 or less, 6 or less. Because once they get real complicated, you have all these pictures and flow arrows, and they gets really funky after a while and can get a little confusing. Okay. This is the proof of alternate exterior angles, but I can't use alternate exterior angles to prove it. So angle 1 is congruent to angle 7. Okay, angle 1 congruent to angle 7. They give it to us. Second step, if I look at 7 and I look at, I'm sorry, if I look at 1 and I look at 3, I can say that they're congruent because they're vertical angles. And most of these proofs actually are like short, and they all are pretty much done in the same way, so that's sort of good in terms of the pattern. Since they both equal 1, they can sit they equal each other. So I can say that angle 3 is congruent to angle 7. Transitive property of congruency. Look, it's exactly like the last one. And since they are congruent and they're in corresponding positioning, bottom right, then I can say that line L is parallel to line M because they are corresponding angles. And this is the converse. Corresponding angles converse. Okay. So that's proving alternate exterior angles theorem. So those are the 2 proofs that we've done. Again, there's the flow chart, and it's exactly the same. Exactly the same. They want us to use the same diagram up here to prove theorem 3.6. This flow is identical to the flow above. Alright, so this is going to be proof of, proof of 3.6. Which one is 3.6? They want us to prove a postulate. Okay, well, let's prove a postulate, guys. That's silly. Very silly. Do 2-column proof. I guess this is proof of same-sided interior. Even though it's a postulate. The book sometimes doesn't make sense. This is one of those times. Okay. I almost don't want to do this because it's ridiculous. Alright, so I'm told that the measure of angle 3 plus the measure of angle 6 equals 180, and it's given to me. So I have 3 and 6, right? The way that I'm going to do this is that I'm going to have 5 and 6 equal to 180 because they're linear pairs, they're supplementary. And then I can substitute 1 for the other. So I'm going to say that angle 5 and angle 6 are linear pairs. Or I could say, I'm sorry, they're supplementary. And they're supplementary because of definition of linear pairs. And since they are supplementary, then the measure of angle 5 plus the measure of angle 6 equals 180. The definition of supplementary angles. Next up, I'm going to set them equal to each other. So I can say measure of angle 3, I'll write angle 3, plus the measure of angle 6 is equal to the measure of angle 5 plus the measure of angle 6. This is because of the transitive property of equality, or you can say substitution. I'm okay with both. Look here. I have a 6 over here and a 6 over here, so I can subtract those bad boys out and make them go bye-bye. You know what? I'm making this harder than it has to be. Let's do this instead. No, I can go the same route. Doesn't matter. Okay. No, this is fine. Because I would still have to do the same thing here. Angle 3 is equal to angle 5. Subtraction property of equality. Then if they're equal, then they're congruent. That should be a measure. Definition of congruency. And then if they are congruent, 3 and 5 are alternating interior angles. So I can say that the two lines are congruent, or I'm sorry, parallel. So L is parallel to M because of the alternating interior angles converse. Yeah, there's such an easier way to do that. Okay, and that's a 7-stepper. I'm not going to ask you to, since this is a postulate, I don't really see the point of you guys knowing that, but okay. Here, they give us that 1 and 2 are alternate exterior angles, and they tell me that they're congruent. So 1 and 2 are on the outside or on opposite sides of the transversal. They're congruent. So if they're congruent, then they mean that then these two lines R and S are parallel. They ask you if it's also, can I also say that they're parallel in another way? Yes. If I know 1 and 2 is congruent, and I know that 3 is congruent to 2, then 1 is also congruent to 3 because of transitive property. So if 1 and 3 are also congruent, they're corresponding angles, I can also say that R is parallel to S. So there's two ways to do that. Here is some algebra. If we want these guys to be parallel, these corresponding angles have to be equal to each other. So we would say 55 is equal to 3W W minus 2. Add 2 to both sides. 58 equals 3W. 57 equals 3W. I don't like the number that's going to come from that. Yeah, that's correct. Divide both sides by 3. Oh, I guess that W equals 19 degrees. All right. All right, so that's that section. Hope you have a great rest of your day.